Record this for later. Yay. All right, so for the most part, this is going to operate exactly the same way that class normally does, minus the bit where I run up and down the aisles. So hopefully everybody's, you know, got to enjoy the snow a little bit. Can everybody hear me just fine?
Yeah, we can hear you.
Great. All right. I'll go ahead and start sharing what I've got for a second. So today's activity, let's go ahead. So home modules, let's check out what's in module 5. So module 5 is the videos with the meat of the for statement and the if statement, where I really get into the for loop, especially the bit about how to do functions. Okay. So lab 4 and 5, it used to be 2 different labs, and I've taken some of the problems from lab 4 and 5 and I've put them in this PDF over here that we'll be doing today. So what for today's activity, it's not going to be on Runestone. Instead, we click here, you'll get this, and there'll be a PDF up here. You'll want to upload it. Yes, and then I'll check it off like it was a normal assignment, but you do not need to demo. Let's go ahead and change the description of this done in class on 2/13. Notify users if this is changed. Bold. Since I get that a lot. Get that question a lot. So let's see. So just a few, again, just if you're joining us here, go to module 5, module 5. And today's activity will be this one. Okay. Now before I do get started though, does anybody have any questions regarding the first the current homework now that you've all been to lab and had a chance to do it? Hopefully you've been going to lab. This is the time where you really want to make sure you're going to lab to get that extra help, if both from the TA and your classmates. Let's see what time when it is due. When do I have it due? February 23rd? Yeah. Do February 23rd because that's when we're going to have our exam. So I'll have more details as to the exam and practice exam on Thursday. But yeah, the exam is going to cover what's on lab 4 and 5, plus maybe a bit of if statements. Okay, you're stuck on the multi-table. Okay, who else is stuck on problem 1.2? Yep, speak up, everybody. You're not the only one, trust me. All right. You're never alone. All right. So, all right. In that case, we will talk about the I'll go over also the turtle loops as well. So let's go. So I'm pulling up in Runestone for a second, just so that I can let's see. Why am I doing it in Runestone? Oh, right. So I can do it with the code lens. That's why. Okay. So let's go ahead and open up. So I've opened up Runestone so we can do this with the code lens. Going to go ahead and zoom the very, very far in. Okay. And now let me just hold on 1 second. Hey, Laser, can you lower the volume just a little on that? My kid's playing Nintendo Switch doing Mario Maker. So just a bit distracting. It was a snow day for him. So anyway. So for loops are, so what is the objective of this 5x5 thing that we're trying to do here? Okay. The objective of the 5x5 is we want to get something out that looks like this. Basically 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 3, 6, 3, 6, 9, and then 12, and then 15. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16, and 4 times 5 is 20. Right, and so on. Okay. So what we need here is essentially we kind of need a nested loop here. There's a few ways to go around doing it without a nested loop, but they require you to be comfortable with lists. So, and since we're not really there yet, we got to use this. Now, there's two ways to view this, okay? Each position in here is essentially two numbers multiplied by each other, okay? Let's call them X and Y. So this is 1 times 1 over here, 1 times 2, and then over here would be 2 times 1 and 2 times 2, okay? And basically, you have an inner for loop and an outer for loop. Your outer for loop goes over maybe the X value, and your inner for loop is the Y value that changes, okay? That's one way to view it. The way I find more useful for people to view it is to view the we're going over the homework for chapter, we're going over the homework for which corresponds to chapter 7 and 8 in our lab 4. So this is 1.2. Okay, so over here we've got this. Now another way to view that is the way I was printing it out, which is that our first row is just 1, 2, 3, 4, 5. Let's see. Yep. 1, 2, 3, 4, 5. Yes, you can draw on the screen, although not particularly useful for everybody. So 1, 2, 3, 4, 5. The second row is also 1, 2, 3, 4, 5, but multiplied by 2. And the third row is also 1, 2, 3, 4, 5. But in this case, we're multiplying by 3. And this first row was just multiplied by 1. Okay. So, way to view this is for each. So, way to view this is for each row, print out, sorry, for each row, for each number 1 through n. I've chose 5 on n, so it's not that. For each number 1 through n, okay. Print out the number, the current number times the row number. Make sense there? Yep. You want to do this as a loop inside of a loop. Get comfortable, because there will be a question on the exam that will require you to read these kind of things, loops inside of loops. They're not so bad once you kind of break it down into, okay, each row is going to be 1 to 5. So I'm going to print out each of those, each number in that row. So you do that inner loop by yourself. So figure out how to do that inner loop first. Print out the numbers 1 through 5 with spaces in between them like that. Okay. And then figure out, okay, how do I print out 5 rows? So step 1. It can be, yeah, you can make row your variable. In fact, I would suggest that. So step 1, print out the numbers 1 through 5. Step 2, print out the numbers 1 through 5, or sorry, 1 through n, multiple times. 3, print out the numbers 1 through n multiplied by the row value, let's call it value. There we go. So that's how you solve that one. Okay. And in case you're furiously copying that down, here it is in chat. So there you go. Okay, so next thing was the question. N is the provided argument. N is the provided argument. So technically what we have is, yes, I don't know if you'll be able to reread the chat, so you'll want to save that. That's what N is. N is basically coming in as an argument. But I mean, you're going to have this, so you can reference it, you know, in the video, these instructions. And you can just hit pause right here to make sure that, you know, you get it down right in your instructions. Now, with regards to the other one that I'm going to go over before we do today's exercise is somebody said that the turtle loop is a little bit confusing. All right, summation of squares is if you're having trouble on summation of squares, you're overcomplicating it. Most you do not. The answer is you print out, if I give you 5, the only thing you print out is that. You don't print out one, you don't print out the equation. Okay. So for summation of squares, what you do is the first step, I'm not going to write this down, just listen to me. First step for summation of squares is print out the values 1 plus 2 plus 3. Sorry, print out this, do a running sum. Okay. Do a running sum of 1 plus 2 plus 3 plus 4 plus 5, which should be 15. Right, is it? Yes, 15. Okay. Then what you do is that instead of doing a running sum of 1 plus 2 plus 3 plus 4 plus 5 or dot, 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 all the way to n, instead what you're doing is 1 squared. So you multiply the value you're multiplying the value you're adding by itself when you're adding it. Or you just do star star 2. So it's very easy to overthink that one because you think, oh, I've got to print out the equation. You don't need to print out the equation. You just need to print out what the answer is. Make sense? So in other words, the because is because I wanted you to understand how we got 55 as the answer. I didn't want you to, but I don't want you to necessarily have to print out 55. Now, with regards to the turtle loops, the reason what we want, that one, if you do each of the things in the turtle loops, you know, in part 2 of lab 4 and 5, so draw square, draw row, draw grid. Okay. If you do that in a different file, each of those in a different file, you're making yourself, you're hurting yourself there, because the entire point of that is to show you that we can use functions to call other functions, right? The idea here is that if I want to draw, I can draw a square. Okay. And then I need to draw, the next function is draw a row. And I can draw the row by drawing a bunch of squares. Okay. And then draw grid is next. And I can draw a grid by drawing a bunch of rows. Okay, so you use the square to draw the grid. So you use the square to draw the row, then you use the row to draw the grid. Make sense? And then you also can use the row to also draw the stairs. Okay, everything kind of builds on each other for that one. Okay. And now my big piece of advice is that if your turtle starts here, right, and you're drawing, you want to make sure your turtle, so if your turtle starts there and is facing this way, you want the turtle to end at this point and face this way. So I didn't have it in that way in the document, but when you draw a row, right, the turtle starts here. And when you're done drawing your row, trust me when I say it's so much easier if you come back here and end up here, because knowing that your turtle, because it makes everything easier when you know when you're doing the next step, the turtle was where you started it. The last three parts are extra credit: the draw, the hash, the slash symbol, the hourglass symbol, and modifying the super spiral to be a super duper spiral. So has that helped everybody? If this is tough, then yes, a lot of these are tough for beginners. That's why I'm giving them to you. Okay, you're not alone in feeling that's tough. You're not dumb for struggling with this one. I have to give you hard ones to struggle with. Okay. Today I'm going to go over some other ones that are same but different. Okay. So we're going to do some problems that are similar but very different at the same time. Okay. What happens if you don't do well on the test? Do better on the next one. But again, you've got a bunch of time there. I mean, I've had to look. It really depends on what your goal for the class is. If your goal if your goal is to get an A, then not doing well on the test would probably hurt those chances. If your goal is to pass the class, then look, if you check out the way that everything is graded, half of your grade comes from stuff that is completely within your control. The final project, the homework, and the textbook exercises, which basically you should be able to get, I'd say, like 49 out of 50 points easy on that. And the rest, it's really hard to get below 50 on the exams, on any of the exams. So I find that basically students, as long as they put in the effort, never score below a 70 ever, which is a passing grade. And then, but honestly, but don't let that scare you. The average is never close to that. It's always in the 70 to 80 range, depending on the semester and the questions. Okay. It's also hard to tell what the average is on the exam. Will we finish the codes from last class? The country one? No, I'm not going to be doing those. You can do those on your own though. But only the parts from part one are graded for that. Okay, so let me go through this now. So let's go ahead and remove these drawings. All right, so today's problems are what I called intermediate. Yeah, the lab. No, it's not a bad question. The labs are the homework. They're labs and homework are the same thing. Not a dumb question at all. So today's questions, I've got 4 of them. Okay. This one was this used to be the old lab 5. Okay. This was old lab 5 before I decided, okay, let's make lab 4 and 5 nice. Let's make it big so that it's one assignment that students have lots of time to work on. Okay. So question 1, number of vowels. Write a function which, given a string, returns the total number of vowels in a string. Okay. So we feed a function, you write a string and return an integer. So returning is not something you have to do in lab 4 and 5. That's not something you have to do, but we're going to I'm going to print out the answer and then I'm going to show you how to return it. And I'll go over what that means. Okay. So, so let's see, 3, and then we've got number of even digits. Given an integer, returns the number of even digits. So 254 should return 2, since only 2 of the digits are even. Okay. A 3-digit Armstrong number is an integer such that the sum of the cube of each digit is equal to the whole number. That's a wordy definition. So the sum of the cube of each digit is equal to the whole number. Write a function that, given an integer, returns whether or not that number is a 3-digit Armstrong number. In the world's a 3-digit Armstrong number? Again, each number is the sum of the cube of the digit. So 371 is this Armstrong number because 3 cubed plus 7 cubed plus 1 cubed, which is 1, is equal to 371. Likewise, 370 is also an Armstrong number because 3 cubed plus 7 cubed plus 0 cubed is equal to 370. Okay, so very similar there. And then we've got this giant for loop question, which honestly seems like the best place to start, which is Riddler. So Holy Digits Batman. The Riddler is planning his next caper somewhere on Pennsylvania Avenue. Now, this problem comes from Savage's Java book that we used to use for 1068. So that's where this comes from. So in his usual sporting fashion, he has left the address in the form of a puzzle. The address on Pennsylvania is a 4-digit number with the following properties. So all 4 digits are different. The digit in the thousands place is 3 times the digit in the tens place. The number is odd, and the sum of the digits is 27. So we could start here, or we could start at number 1. Any preference? Okay. So yeah, this one's a fun one. And let's go ahead and do it first because I do have a tendency, I feel sometimes, to run out of time here. Let's go ahead and forgive me for those of you who are for those of you on tiny screen. Yeah, you'll be submitting this as a Python file, as uploading your code as a Python file. So forgive me for those of you who are on a tiny screen. This may or may not be terrible for you. So there we go. So everybody should be able to see my entire screen now, right? So we've got idle. So let's go ahead. I'm going to go. So, right, rather than having to refer back to this multiple times, sometimes it's better to do this, copy. And I'll drop it in a comment. See that? Now I've got it in front of me. Don't need this anymore while I'm working on the problem. Makes sense? Reduce the amount of window switching you do, right? So Holy Digits Batman, the Riddler's planning to use his next caper. So we're looking for a 4-digit number with all the following properties. Okay. And we'll go over those properties in a second. Write a function that uses a loop or loops to return the address where the Riddler plans to strike. Now this one, it requires us to use something that we don't really need to use in lab 4 and 5, which is the if statement. You can kind of see how that, but we'll see, because we really only need to check equality here. All right. So 4-digit with the following properties. So let's go ahead and do def Riddler. So we've defined a function called Riddler. And that pass is basically meaning fill in so that I can run the code. And the way functions again work is that basically calling Riddler. And these lines are going to get deleted very quickly in Riddler. We can erase that there. The pass is just basically reflex on it's basically a twitch on my part, essentially. And done with Riddler. And now you can think of a function. A function goes by a couple different names depending on the context and the programming language you're using. In Python, we just refer to them as functions. You may hear them in Java or object-oriented programming context referred to as methods. And if you're coming at this from an older programming language, we use a word like subroutine or subprocess, which, if you think about it, actually makes sense. These are like tiny programs we're going to write inside the program. So save. Let's see. Desktop. Loop. Let's just add a bunch of O's there. Loops. Okay, because why not? So I run it, and again, way Python works is that it reads this file top to bottom. It says, aha, a string, just a string hanging out. Cool, I'll ignore it. Def Riddler. Okay, they're defining a command called Riddler. I'm not going to worry about anything in this indentation until the Riddler is called. But it says, aha, they've added a new verb to my language. It's called Riddler. Great. I'm not going to worry about what it is until they call it. Then it goes and sees, print statement, print out calling Riddler. Aha, Riddler. Well, I didn't know what that was, but they said they've defined it. So now we're going to jump to Riddler and run whatever in there. Once we're done with everything in Riddler, once we're outside of that indentation of this Riddler, of this stuff so notice that this print statement is indented into Riddler. Now that we're outside of that, we're done with it. So we called calling Riddler, done with Riddler. Okay. So this one doesn't need an argument, unlike the other ones, but we're looking for a 4-digit number that has the following properties. Okay. So first off, all 4 digits are, first off, yeah, so we're looking for a 4-digit number. Now, how do we look through all 4 possible 4-digit numbers? We'll use a for loop. Ironically enough, it's a nice homologism, homonym. Okay, for homolog. It's one of the two. For num in range. Now we want to go through. We want to check all numbers in the range that are 4,000. 1, 0, 0, 0, comma, and go up to, but do not include 10,000, right? And if I do this, right, so here's all the possible candidates now. That's going to take a while. In fact, it's going to take way too long. So there we go. So now the idea is to go from all these 9,000 possible candidates and whittle it down by using these. All 4 digits are different. The digit in the thousands place is 3 times the digits that's in the tens place. The number is odd, and the sum of the digits is 27. Now, some of these we need if statements for. Let's go ahead and put out those. Okay. So some of these we need if statements for, but actually some of these we can be clever about. The number is odd. Well, we can be clever about that by manipulating the for loop we are writing. If we change the range, this range to be, let's start at 1001, right? Because it can't be 1,000, right? Can't be 1,000, right? So 1001 through 10,000, and then up to, but not including 10,000. And then if we go up by 2s, so that'd be 1001, 1003, 1005. You can see it on the side over here, right? Let's now terminate it. Come on, terminate. There we go. Or not. Whatever. There we go. As you can see, it's going up by odd numbers right there. Okay. So it's going up by odd numbers. So that's great. So we have done that one. Okay. All 4 digits are different. The digits in the thousands place are 3 times the digits in the 10 place, and the sum of the digits is 27. Before we can do this, this means that we probably have to break out. We have to take a look at the number and break it into its individual digits. Now there's two ways we can do this. The first way is a bit weird, in my opinion, but it's very direct, which is you go and turn this into a string, okay? And then we basically say, okay, the thousands is index 0, the index 1 is the hundreds place, and so on and so forth. This means start at 1000. This means start at 1001, go up to, but don't include 10,000. So all the numbers from 1001 to 10,000, not including the 10,000. And then the 2 means go up by 2. Start point, end point, step. So without this, it would do every number. It would go 1001, 1002. Here we're going 1002, 1003, 1005. Okay. So now, so we need to extract all these digits. Now the other thing, normally I would torture the class with this because we'd done the other exercises first. But right now what we're going to do is that we are going to, So one way we could do this is we could say, number string is equal to num, and we could do this. We could say thousands is equal to, it's not including the 10,000 because ranges are always because the ranges always go with this kind of mathematical formula, which is start, comma, end. Never include the end point. Always include the start point, never include the end point. 1000 is equal to num. So the thousands place is equal to num 0. Actually, sorry, string. So getting back on track, one way we can get the individual digits, because that's what we need to do in order to do the other checks, is that we can say string, we can convert that number into a string. Then we can say, hey, convert that string. We can take the first thing in the string, the thing at index 0, and convert it into a integer and store it like that. And then we could do the hundreds place, tons, tens, assuming I could type. This is not the way we're going to do it, but because again, we're using stuff that I'm not really going to test too much over here. And then 3, right? Index 0, index 1, index 2, index 3, but you got to convert it into a string in order to do it like that. But that's a rather lopsided and weird way to do that. So I'm just gonna comment it out. That's not how I want to do that. Instead, what we can do is, what I prefer to do is to use math because it's quicker for your computer and less operations to do. And it is also important to learn how to use math. Okay. So how do I use math to get each individual digit? It's a bit weird. Okay, but we have two tools in our toolbox for that. We have divide, and we have mod in order to do that. Okay, those are the tools we're going to use. What do I mean like that? Well, suppose I've got over here, look on the right-hand side now. Okay, so we're going to look on the right-hand side over here. So suppose I've got a number like this, 4, 5, 6, 7, right? If I do 4, 5, 6, 7, and I do divide 10, that chops off the last digit. 4, 5, 6, 7 divided by 100, it just gives me the thousands place and hundreds place. Make sense? Right? We're just doing the quotient here. So you can think of this as like throwing away a digit. This throws away 2 digits. 4, 5, 6, 7. It's a weird way to think about division, right? You're just throwing away digits. It works when you're dealing with 10, though. So 4,000 something 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 divided by 1,000 is going to give us 4,000. Specifically, it's going to get us 4 remainder 567, right? Everybody follow that so far? So we know this is going to be a 4-digit number. So we can just type over here on the left, 1000 is equal to the number, is equal to our number. Actually, I even didn't even do that right. Technically over above, this should have been this. Okay. Anyway. 1000 is equal to number divided by 1000. Go. The other tool that we have that they said we have is the modulo. 4, 5, 6, 7. And let's just play around with that for a bit. 4, 5, 6, 7 divided by, mod 1000, right? Dividing by 1000 gives us 4. Modding by 1000 gives us everything that didn't fit into being divided by 1000. It gives us the remainder. 4 remainder 6, 7, 6. Sorry, 4 remainder 5, 6, 7. So let's do 4, 5, 6, 7 mod 100. So instead of throwing away the last 2 digits over here, it gave us the last 2 digits. See that, everybody? Everybody following along? So 4, 5, 6, 7 mod 10 gives us the last digit. All right. So take a couple minutes to try to fill this part out on your own. Okay. We're going to reuse this quite a bit. So give me a second. I'll be right back. But use a few minutes to try to figure that out on your own. Key here is, so the key here is to view this as kind of tools for removing either digits from the left or digits from the right. That's the key here. You can use division to remove digits from the right of a number, and you can use modulo to delete digits on the left. Make sense? Specifically modulo by a power of 10 and divide by a power of 10. Like oh, I've never viewed it that way before because you've never had to. So does anybody want to give me what is over here for the ones place? You can either speak up or you can drop it into chat. Yes, please. Joshua.
For the ones place, I just did like modulo 10.
Yep, modulo 10. Any number divide. Yep, exactly right. Everybody who got that. Just modding by 10 always will give you the ones place of anything. All right, those are the easy ones. Now, what about the tens or the huns? Anybody want tens place or the hundreds place? Joshua again.
So for the for the hundreds plates, I did just like divide by 100, and then I did modulo 10.
Let's see. So let's see if we take. I'm gonna test on the right over here. So 4, 5, 6, 7. Did you say modulo by 100 or what was it? Modulo by 100?
No, divide by
100.
100. Yeah.
Divide by 100. So if we divide by 100, right, that gives us that. And then you modulo by 10 to get the last digit of that. Right?
Yes.
Mod 10, right? And this is, and again, this isn't necessarily intuitive, but just like, but like in terms of order operation, division and modulo and multiplication are all on the same level. So we did this to throw away the last 2 digits, and then we got the last digit of what was left by modding by 10. So num divide 100 mod by 10. All right. Anybody else want to do the tens place instead? I think I see it from Cora in chat. So let's see. From Cora in chat, we got 4, 5, 6, 7. Modding by 100 throws those two away. And then divided by 10 throws that away. Right? This throws away everything but the last two digits. This throws away everything but the last two digits. And this throws away the last digit. Are there other ways to do it? Yes, definitely, 100%. As long as it works, it's fine. For the tens place, another way you could do that is that you could divide by 10, right? To get any, and then you could mod by 10. That's another way to do that. Divide by 10 and then mod by 10. Divide by 10 to throw away the last digit and then get the last digit of what remains. It's math. There's multiple ways to do a lot of things. Okay. So now we've got this, and we can actually now attack those if statements. All 4 digits are different. So this one is just an annoyingly big if statement. So instead, let's go ahead, instead of focusing on that, let's focus on the smaller one. The sum of the digits is 27. So if, so this is the way an if statement works. And we're going to get a lot of practice with only if statements on Thursday. If 1,000 plus hundreds plus tens, right? If those plus 1, so if this all together plus ones, if that all together is equal to 27, that's how you write that kind of check. If those things are equal to 27, and then here's what we'll do. So only if that number is equal to 27 will we print it out. And so now we're printing out a lot less numbers. So notice that this is 1 plus 8. So that's 9 plus 9 plus 9. So 3 9s together make 27. Similar over here. 3 9s make 27. 2 plus 7 is 9, then 9 and 9. Okay. So that's why so that's how that if statement works. The digit in the thousands place is 3 times the digits of the tens place. So we'll put in another if statement inside that. This is like saying if this and if this. We could also do an and statement, but we're not going to overcomplicate that in a second. So let's see. If the digits in the thousands place is 3 times the digits in the tens place. Okay. So if thousands, and we can actually translate this directly. If thousands is equal to 3 times the tens place. So the doubles. So if you watch, so you'll need to watch the video on on if statements. Because this may be your first experience to if statements. That's fine. But what the equal sign does is that this one equal sign means assignment. Store this value inside here. An equal sign is one of the comparison tools we have. And the reason we use 2 equal signs is because to differentiate it from the single equal sign. But when I say comparison tools, I mean we have equal equals, less than equal to, greater than equal to, less than, so less than, greater than, and then not equal to, right? Those are your kind of comparison tools that you've always used. Although, right, when you're writing it in mathematics, you typically like do a not equal to some, you cross through that, right? So this is how you kind of always write them in, like when you're typing them out. So equal equals, less than equal to, greater than equal to, less than, greater than. So those are your tools. And when viewed in the context of these guys over here, it doesn't look so out of place. But the reason we use 2 is to differentiate it between the assignment statement. Okay. Okay, and so now if we run this now, we get only 2 answers. 3 times the digit in the tens place. The digit in the thousands place is 3 times the digit in the tens place. The way the modulo operation works is that it takes away the digits on the left side. Because what modulo is that this is division. Okay. This is division. And this is division that gives you the quotient, right? So go back to 4th grade math with long division. Because you haven't had to think about that for a while. Right. And when you did that kind of math, you would do division and you get the quotient and you'd get the remainder. This gives you the quotient, which is, okay, x divided by y equals z. It gives you z. Modulo gives you the remainder, that bit left over that can't be divided by y. So when you modulo something by 10, it's giving you basically, when you divide something by 10, basically that's, so for instance, 567, you'd get 56 when divided by 10. Modulo by 10, that gives you what would be left over. 567, what's left over would be the 7. It's something that's worth experimenting with. And here I'm saying is that we can kind of use that effect as tools. That instead of doing division, do digit manipulation. Okay. We may not have the chance to get to all of them, and that's fine. Okay. So now what we're going to do over here is we are going to, now this last one's actually is all 4 digits are different. And that one's actually fairly straightforward to write. I'm going to actually write it on top here and indent everything else. Okay. This one's actually fairly straightforward to write. It just is terrible to write. Okay. So if thou is equal to hun, and so the and basically works exactly like a logic, like you would in it like you think it would work. All the things have to be true for an and to be true. So if thou is not equal to hun, so they've got to be different. If the thousands place is not equal to 100 place and the thousands place is not equal to the tens place, and the thousands, not thous, just thou, and thou is, because I kept it at 4 letters, is not equal to 1. Now, the most common mistake I see is something like this, where the students just do this. Yep, that is an exclamation mark for not equal. Yeah, I didn't realize that. Yeah, so again, this is probably your first exposure to is statements, which is fine. I think this is a good kind of first exposure because it's a lot more difficult than anything you'll see on the exam. A lot more difficult. So in case you missed that, this is a lot more. If you used ands, so somebody's saying if you use the and symbol, that's Python doesn't do ands like that. If you use ands, you're gonna be getting you're gonna be doing some math instead. 9, let's see, 7 and 9. Yeah, you can't do that. And if you used an and symbol, 7 and 9, that actually does math. Weird math that you don't want, that I don't want to scare people about. It's weird math, and I never use, and I think I could count the number of times I've used it on one hand. Thou and huns, thou and 10, thous and ones, and huns is not equal to the tens. So we've checked the thousands again that are not equal to all the others. Now we say, and the huns are not equal to the tens, and the huns are not equal to the ones, not equal to the ones, and the huns are, and the tens are not equal to the ones. So that's all of them. I don't have to check the tens against the hundreds place because I've checked the hundreds against the tens place. If it's not equal one way, it's not going to be equal the other way. And now if I run this, I get 9837 as our answer. Let's go ahead and copy, paste, drop this into the chat. It's too long. Boo. let's just, what if I do this? There we go. That's fine. Or, I can just send the file when I'm done. So we have half an hour left. So I want to make sure, which is about 10 minutes each on the rest of the problems. Okay. So if statements, not going to be nearly as tough on the exam, if they appear at all. But they're really, because they're fairly straightforward if statements. But we'll get into them in more detail later. There's a drop box. There's a drop box here. That is not equal to Huns, and Huns is not equal to tens. No, because that wouldn't check. So because that wouldn't check all possibilities. Right? You could try. So when the person who sent me that message, check against, like, try to falsify that hypothesis. I mean, prove that wrong. Right? Prove it wrong, and you'll find that you can. But anyway, yeah, if you go to the loop and function exercises under module 5, you'll be able to find it. Right, which is right here, module 5. Okay, so let's go back to what the exercises actually say. So we're going to do a much simpler exercise now. Much simpler. Number of vowels, write a function which, given a string, returns the total number of vowels that were in the string. Vowels are only A, E, I, O, U. Okay, only A, E, I, O, U, and we'll assume that it's lowercase. Make sense? It says return an integer. For right now, we'll print an integer. Okay, so I'll write you a method stub, as I call it, to get you started. Def num vowels. It's going to take in some string. I'll call it word. And you want to tell me how many vowels are in this string. Count. We'll call it a count is equal to 0. And then you'll want to print out the count. Not putting it in parentheses is an old Python 2 thing. If that's what yes, you should be up to chapter 7 by now. Again, if you haven't done all the textbook exercises, now's a good time to catch up on them. There's no penalty for being late on them. So here we'll just call count, not count, num vowels. And we'll give it tacos as the vowel. Sorry, as our word. So how do we count all the vowels before I leave you to it? How do you count all the vowels? So how do you know what ones to do? So first, besides your weekly assignment, right? You have the list of the things to do over here. That will bring you over here, which says do this by this due date over here. Make sense? And I think I probably need to modify those functions and let's see. Oh, wow. Give me a second. That first taste of function should be way up. I don't know why that is where it is. First taste of function should be way up. Again, there's no penalty for it being late. So, but this is basically try to be, try to get, so there it's now on par with the rest of the readings. So there we go. The test is up to what chapter? Test would I'd say the tester would be up to chapter 7, maybe a little bit of 8, depending. Maybe a little bit, depending on what I'm seeing, a little bit of 8. And then definitely the first taste of functions, which is like 12. Sorry, let's see what first taste of function is, which is 12.1 through 4. So the first 7 chapters. It primarily is focused on for loops and turtles. Okay. Before that panics you. It's basically everything you need to learn to do for loops and turtles. Okay. So let's go back to this. So how do we solve this particular problem? Yep, we give it a list of existing val and yeah, it returns the ones that are present in the string. We would actually just count. It's a running sum. And basically what we do is so the way you want to approach this one is you write a for loop. Check every letter in word. So check every letter in word. If that letter is a vowel, add 1 to your count. That's it. So try to turn this into a bit of code. For every letter. No, I'll talk about the test no, count is not an index. I will talk about the exam at the end of class. I can't answer more questions about it right now. It's going to eat up all the time. Okay. I will answer. Okay. For every letter in word. For every letter in word. Check if letter is a vowel. If it is, and don't worry about what if it's not a vowel. Okay. So go ahead and try that. There's a reason why the test is next Friday, not this Friday, but next Friday. So. Nope, no user input. Notice I've never put any user input in here. The input was just simply because you didn't know how to use functions yet. So I've done things with input, and now I've got to break it. The input was a habit, so now we got to break that habit. All right. So let's do this now. Yep. Something like that's one way to do it. But honestly, it's a bit easy, but it's easier if we don't. But if you're coming from a different language, stop thinking about indexes for unless you absolutely need the index. For letter. It's so much easier if we do this. For each letter in the word. If letter equals A or letter equals E. So yes, we have an and statement and we have an or statement. Yes, letter is equal to I, and so on and so forth. The most common mistake I'll see is this. Yeah. And when I chose this assignment today, I'd completely forgot that I'd pushed back the due date of reading if statements for Friday. So that's my bad. But good exposure to it for the first time, I think. So if you're kind of lost, don't worry about it. Right? And somebody's asking the correct question. Is there a way to simplify this? Well, let me write it out the long way and then I'll write it the short way. If letter is equal to E or I or letter equals O or letter equals U. Oof, that's a big one. Count plus equals 1. Increment count by 1. And so we can kind of see this happen here. 2. So we've got, right, because tacos has 2 letters. That's exactly correct, Gabby. That is exactly correct. So there's a simpler way to do this. Bit of a simpler way, and I love this feature in Python. It's to make use of this keyword, the in keyword. So here we've used it to iterate over something, but we can also use it as a logical expression. That's exactly right. That's exactly where I've gone. So for Cora, for your code, you want word is equal to word dot lower. So anyway, for letter in Word, what we can do over here is we could create a vowels, and rather than doing string list, I'm just going to do a string called vowels is equal to A-E-I-O-U. Okay. And this is why I like this, because once you see it, you're like, oh, that feels very natural. It reads very naturally in English. If letter in vowels. For letter in Word, if the letter is in vowels. What does that mean to be in it? If it's one of the letters in here, if it's one of the things, if it's contained inside this collection, if letter is in A-E-I-O-U. Make sense? And again, if you're feeling lost, it's because this is a bit weird. I'm doing the reverse of what you would normally be doing, which is I'm doing the hard things in the lecture, and the textbook readings, those are the easier things to do. I'm leaving that for you to do. That's why it feels why it feels lost sometime. But I want rather the stuff that you have to do by yourself be easier. So for letter in Word, if letter in vowels can't count plus equal, there is a method to my madness, I swear. Two. For letter in words, if letter in vowels, increment the count. So that is that one, right? So what we do is we just simply set up a vowels. We went through every letter and asked, is that letter in vowels? Great, increment the count. Now, when it says return, by the way, this is an input into the function. Return just gives me an output to the function. So so if I do that, you'll notice that I don't print anything out anymore. What returning does, okay, this is your introduction to returning, is that it allows me, printing is only useful for the user. So here I can take what I get from a function and put it in and take what gets returned and put it into and store it somewhere so that maybe another function can use it. We will be transitioning over to doing this for lab 6. Okay. When we get to lab 6. Okay. Now, let's go ahead and look at, since we have 15 more minutes, number of even digits. Okay. Write a function which, given a digit, returns the number of even digits in the integer. Okay. So how do I tell if a number is even, first off? Okay. How do I tell if a number is even? So the way I tell if a number is even is that we're going to use that tool that you're coming to hate. This is basically, but honestly, we only really use it in 2 places. We use it here. We use it modulo by a multiple of 10 to throw away digits. And then we use it here to check if things are even. So for instance, here, 4 mod 2 is equal to 0. 4 divided by 2 gives you no remainder. 5 divided by 2 gives a remainder of 1. 6 divided by 2 gives a remainder of 0. 7 mod divided by 2 gives a remainder of, 7 divided by 2 gives a remainder of 1. So even numbers have a when you divide numbers by 2, even numbers have a remainder of 0, odd numbers have a remainder of 1. Makes sense, right? So what we can do is we can throw this into an if statement. Something like 7 mod. So if I say 6 mod 2 equals 0. And if this, you need to, and you don't need to do this, but if it makes you feel better, you can say, okay, if this mod by 2, if that's equal to 0, then that's even. And then if I do this, 5 mod by 2 is equal to 0, we're going to get false because it's an odd number. So that's how we tell if a number is even or odd. Okay. So now I'll go ahead and just straightforward do this one because we're running out of time. Maybe I'll just focus on this one and not do the 3-digit Armstrong. I think that's the best one. You can give this one the full attention it deserves rather than rushing through it. So def. Num digits. Have I given this as a question on an exam before? Yes, I have. No, that nobody asked that. I have given this one as a question on an exam before, though. Number of digits of a number. Not number digits, but number even digits. Okay. So if I'm trying to count the number of things that occur, I'll do count and I'll print out that count. We'll eventually turn that print into a return as we at some point, as we learn more about return. Right now, count is equal to 0. We'll print out that count. And so what we need to do is that we need to iterate through every digit in the number. Which, unfortunately, if we try to do it like this, just for an example, just for kicks, def, I'm sorry, num even digits, right? How many even digits are in that? Unfortunately, we get an error on that line. See, the errors are actually helpful. It tells you, hey, in line 57, that function on line 53 which had this, we got this error. You can't iterate over a number. Okay. Because that would be ambiguous. Do you want the range or do you want to go through each digit? So one way to go through that is say, hey, I want to turn this into a string. And for simplicity's sake, that's how we'll do this now for right now. We're going to keep it rather simple, right? Let's keep this really simple and rather than relying on math, we're going to just do it. We're going to do it very simple to this. We're not even going to bother with the modular arithmetic. We're just going to keep it simple like the other one. Okay. Evens is equal to, so what are the even digits? 0, 2, 4, 6, 8. Those are the even digits, right? So 4-digit in string number. If digit, so this turned it into a string. So I can iterate over it now like it's a string. If digit in evens, count plus equals 1. There we go. And 2, 4, 6, 8. So yeah, there's 4. But what about if I didn't want to do it like this? Instead, I actually wanted to check the value. Okay, for int digit. Sorry, if int digit, turn that. So we turned that into a string so we could get the individual digit. Then we would have to convert it back modulo by see, modulo by 10. Sorry, modulo by 2 equals 0. Sorry, I'm lost in thought for a second about where this assignment should be. And I think I pulled this assignment way too early up front. I'm like, oh, we can do lab 5 right now. It's week 5. No, this was a bit of a mistake, but hey, I'm also teaching you if statements and we're reviewing for loops, so not too much of a mistake. Just so it's just a much harder day, and I think people are more lost than they need to be as a result. So I apologize for that. So if you're feeling lost, what I'm saying is don't worry about it. It's fine. So if int digit mod 0, sorry, mod 2 is equal to 0, cap plus 1. So convert it back into an integer, mod 2 equal 0. So this is the only way to really, so notice that we're doing a lot of converting here, and there's really no way to get about doing that amount of converting unless we actually use math, and that would require us to use the modulo statement, mod by 10 and divide by 10. But I don't want to do that because that would also involve us having to do the while loop, and I don't want to do and no, it's too early for the while loop right now. So yeah, my only excuse as to why I thought this was a good idea is that I only got 4 hours of sleep last night. So, which is part of the reason why I sent out the email. We had a late night medical emergency, so I stayed up. Everything's fine. So, but yeah, this was a mild error in judgment. But everybody's following. It seems like everybody's following along okay. Yes? No? Everybody's so quiet. I think I've scared everybody. Trying, yes, definitely. Yeah, no, I make mistakes sometimes. So, okay. So for some of you, this is more valuable than others. Let's go ahead and give you what you need to submit, and then I'm going to talk about the exam itself, okay? So let's go ahead and stop sharing. So, okay, so here you go. So in terms of what you submit, yes, you need to submit it. And here's your code. There you go. So I just shared it in the chat. What? I didn't need to write it down? It would have been, yeah. But trust me, you got a lot more out of it if you did that. Don't worry about the one you didn't do. Don't worry about the 3-digit Armstrong number. Okay. So now where do you submit it to? You submit it to here, which is under modules. Where do you? Yep, pretty much. But it's honestly the code that matters. So if you go to modules 5, it should have been here. And notice that it was here before the blame Pope Gregory, so I typically do this actually next week. No wonder everybody was so lost. And I'm like, well, this seems so wrong. Again, I can only blame it on the amount of sleep I had. Should have done the blame Pope Gregory, so we're going to definitely do the blame Pope Gregory the 13th yeah, you can paste it in. Sure. So we're definitely going to do this exercise on Thursday. This should be a lot easier. You also only have to worry about if statements for that one. So we're going to be learning basically just how to just do if statements for that one. Okay. So ignore this. This is old for online exam. Again, the exam is going to be in person. I'm debating whether or not, did I say whether you get a cheat sheet or not? Because or a note sheet. Okay, great. Sure. Okay, you can have a sheet front and back. It's fine. Handwritten or typed, I don't care. Okay. Let's go ahead and I'm just going to go ahead and share the practice exam from last semester. Why not? One second. So practice exam 1. Let's go ahead and document, course documents. It's already in here. Like I said, I'm moving a bit slower than normal because I'm just very tired. Okay, practice problems 1. That should be fine. Okay. What is going on here? I'm checking to make sure that it's okay. Why are you downloading at 8 kilobits a second? What is that nonsense about? What is going on? I'm sorry. I'm trying to share the code. Sorry, the practice exam with you all, but it's like going. Okay, it is there. Glad I checked it. That's the wrong one. And that's. I think this is the final exam practice problems. So, I'm sorry. Let's see. Oh, there it is. That's much better. Yep, we are definitely doing blame Pope Gregory on Thursday. Key, no. Don't give out keys for my fine. I don't give out a key. I'll make one. I'll make one in class. And you should have gotten an announcement on Canvas. Okay. So here we go. So there we go. I've just sent this out. Okay. So useful notes. The practice exam is much longer and somewhat harder than the actual exam, as more practice better. If you want to time yourself, I would give you 2 hours. The points, not the space, correspond to the difficulty of the problem on the exam. The amount of space does not correspond to the difficulty of the problem. Okay. Feel free to read this out later. So, okay. First off, like I showed you last time, there's some true false here, some of those exercises, but most of this is most of this stuff is covered in chapter 1 through 7. Chapter 8 covers the if statement and the Boolean statements. So, probably the most valuable, the most expensive questions, I would say, are questions like these, where I say, draw the turtle below. And given this code or given this picture, give me code that would draw that picture. Okay. A lot of these, again, are specifically practice problems. Please note when I say it's intentionally made to confuse you, it's there to teach you a lesson. You'll also notice again that there's problems with a 0 point. So now when is the exam? When is the exam? So the exam is during lab. Let's see, this is week 5, so it would be during lab 6 for you. So that's either on the 23rd or the 26th, depending 23rd or 26th, so the Friday or the Monday, depending. Everybody got that? 23rd or 26th? So you've got 10 to 13 whole days. And you'll notice that these problems are actually a lot easy when you go over these problems, like this one. You'll notice that they're a lot easier than the problems in lab 5. Sorry, lab 4 and 5. So print limit, print 3s, and then I have a ton of extra of super duper hard problems over here. Yes, that is what I was going to say. We are doing review that Thursday. I will go over the answers for the practice exam on that. No, the Armstrong numbers we didn't do. So these problems will be, so these last problems, the ones that are worth 0 points under additional practice, if you can do these problems, you're probably going to get an A. Okay. That's what basically what comes down to. If you can do those problems, you'll probably get an A. Although note that none of them go over turtles. So I just sent it out on Canvas, in an announcement. So you should be able to get it. So you should have gotten it in an email. So, announcements. And you'll get the email over here. Sound good? All right, so it is 3:22. So class is dismissed. So if you need to speak with me, I am gonna stick around for a little bit longer. Let's see. One sec, Manifest. Yeah, I can take some lab demos. Just give me a sec. I need to stop recording.
I had asked about the text